Here's our panelist lineup for today. Again, my name is Aria Chambers. I'm a marketing specialist for Banks Industrial Group and Repair Technology. With us, we also have Ajay Patel. He's our business development manager and has over a decade of experience in the oil and gas industry, including business planning and optimization. He'll provide us with an overview of how current events have led us to the current crude oil inventory challenges. Also, we have Dave Arnholt with us. He's our product manager who has over 25 years of experience in the industrial environment, with the past 10 years leading installation projects and more at Banks Industrial Group. Here's a quick overview of our topics we'll discuss today. We're just going to go through how current events are impacting oil storage, options for crude oil storage, types of installation systems, non-weld tank repairs, and corrosion preventative tank maintenance. And with that, I'll pass it over to Ajay to get us started.
Thanks for the introduction, Aria. Good morning to everybody out there. Hope everybody's enjoying their Thursday. So as Aria mentioned, I really just wanted to do kind of a quick overview of the current situation with crude oil refining, and really just discuss how it's a truly global supply chain. So the image that you see on your screen is actually a snapshot of tanker movements in the world right now. So that's tankers filled with crude oil, tankers filled with crude oil finished products. And as you can see, there's a lot of them out there, and they're moving to just about every corner of the world. And so this is why it is a truly global supply chain. And it's because crude oils vary greatly in the type of finished products that they ultimately yield. When you couple this with drastically varying needs of those finished products from region to region globally, you'll understand why it's normal for there to be this much movement. So for example, a crude oil that may be produced in one part of the world will ultimately end up in another part of the world, while a refiner in the same part of the world where that crude oil came from will purchase a crude oil from another part of the world because there's just a better fit. All of this activity and the delicate balance that keeps it going is really driven by the fundamentals of supply and demand. So let's talk a little bit about timing now. So when you purchase crude oil, it's not as simple as going out and calling somebody and saying, hey, I need some crude oil. They're normally purchased on a contract, and that purchase generally takes place between 30 and 90 days out, depending upon the origin and the destination. So a really great example is a crude that's meant to arrive in May, the month we're in now, could very well have been purchased in February or before that. And it's quite normal and doesn't generally create many problems. In fact, forward markets are relatively predictable. We have a lot of history. We understand seasonal patterns when it comes to the ultimate purchases made when it comes to crude oil products. So we can figure out when and how much crude oil we should generally buy. It really places the risk under the reliability of the production, which is taking the crude oil out of the ground, the logistics, moving it to and from place A to place B, and ultimately the refining portions of the business. However, we're living in a different time right now. In the past few months, we've seen a huge imbalance to this system, and they're mainly driven by some major global events. So if we take a look back, halfway through February, the International Energy Association looked at and saw what the economic impact being caused by coronavirus in Asia and Europe, and for the first time in over a decade, actually forecasted a shrink in global oil demand. A few weeks later in March, Saudi Arabia and Russia engaged in an oil war, where Saudi Arabia began the process of overproducing its own oil wells in order to flood the market with supply and lower the price, thus pushing Russia out of the oil markets. Consequently, a week later, coronavirus really began to make major impacts on the US economy, with the President of the United States positioning the country such that we went into a semi-quarantine to help slow down the pandemic. About a month later, we saw the impact on crude oil. For the first time in history, the US standard, WTI, sold for minus $37 a barrel, which is the lowest price ever. So this abrupt slowdown in demand caused a few problems. One, refinery utilization, normally at 90% or more during this time of year, has dropped to 68%. In other words, refineries aren't using as much crude oil because they don't need to make as much product. Well, they've already purchased the crudes in many cases. So this crude that was purchased back in February is still arriving. So what do you do with it? You can't just put it away in a corner somewhere. You have to store it in approved tankage systems. And what we've seen is an increase over that same period of 46% crude storage utilization up to 62%. This shows how the system is out of balance. So the next idea is, okay, if we're filling up our crude tanks, some parts of the U.S. are seeing 100% or close to 100% utilization. We have these major tankers that are moving the crude. Why can't we just keep them on there? Well, 6 months ago, you would have spent about $1.2 million a month in doing so. Today, it's over $5 million. So what does this mean for folks who operate crude storage facilities? It means that storage capacity is at a premium. With domestic capacity continuing to decrease in availability, with some parts of the US at maximum levels, there's an incentive to ensure that your existing tanks remain reliable, and possibly exploring options to expand capacity through repurposing existing tanks that may have been used for heavier feedstocks, such as VGO or LVGO. Another option is potentially look at your out-of-service tanks and explore what would it take to revitalize those tanks and use them for crude storage. So our purpose today is to show you how we can help you accomplish those goals with our tank installation and on-stream repairs. So from here, I'm going to kick it over to Dave Arnholt. He is our in-house expert when it comes to all things tanks, and he's popped up on the screen. So Dave, I'm going to go ahead and let you take it from here. Thanks, everybody.
Thanks so much, Ajay, and good morning, everyone. Hope everyone's families are all healthy. So just to build off of what Ajay was saying, you know, we're seeing a lot of the capacity getting used up with tanks throughout the country, and we just want to talk a little bit more about how you can get those tanks up and running somewhat quickly. So the three things I'd like to touch on would be insulation systems and the different types that are out there, corrosion protection for these systems, and then also some non-welded and welded repairs that'll help protect your tanks. So insulation systems, there's a couple out there. The horizontal panel system is one of the oldest systems that's out there today. You can see these date back all the way into the 60s and 70s. It basically consists of a 4 foot by 8 foot long insulation panel, and it's got the exterior aluminum covering, and then you can see right here in these pictures that there's an exterior band that holds that insulation up against the tank. So again, this is an older system that you'll still see in place today. Then there's the corrugated panel system, and this we can almost say is a conventional insulation system. Consists of insulation underneath of the corrugated metal panels, and what they do is they weld stick pins onto the side walls of the tank, and then you place your aluminum panel and insulation over top of this, and a washer basically holds that panel in place. And again, this is the more conventional system. The gold standard, and what you see most commonly today, is the vertical panel insulation system. Any tanks that are either going to have the insulation stripped off, or if it's a brand new tank, this is typically the insulation system that is going to be put on the tank. And it consists of, it's a fairly simple system. It consists of stainless steel cables that get wrapped around the tank on 3 foot centers. And what you do is you take a stainless steel strap that you see here wrapped around that cable, and you bring it up in between two insulation panels. You bring those two panels together, and then you mechanically seam one panel to the other. One panel is going to have a male leg, the other panel is going to have a female leg, and this gets double folded or double seamed put onto it. Down at the bottom of the tank, you have a critical weld right here at the base, and many times customers want to have that weld exposed. They want to be able to see that, inspect it. So what we'll do is we'll build an insulation support system, say anywhere from 6 to 18 inches above the concrete foundation, above that critical weld. And the purpose is it's going to support the insulation. It'll allow any potential moisture that gets back behind the insulation to flow through. You can see that there's a bit of a gap here, and it'll flow through and just drop right to the ground and evaporate. This particular system is a non-welded system where you can see these legs that are bolted onto this angle. And then we've got a stainless steel cable that wraps around those legs and keeps everything up against the sidewall of the tank. And we would call this a non-welded insulation support system versus a welded system. So you could see it's basically the same thing. You've got your aluminum angle that's supporting the insulation above, but we've got clips underneath of that aluminum angle that are welded to the tank, and they're about every 4 foot going all the way around, and that just gets bolted to that angle. And again, performs the same function, supports the insulation up above, keeps that corner weld exposed for inspection purposes, and also to allow moisture to just to evaporate away from the sidewalls of the tank. Roof insulation. So the insulation on the roof is attached a little bit differently than the sidewalls. Instead of using cables, we use a 3/8 inch round bar, and this is a real common attachment system for roof insulation systems. This round bar is attached to the tank in a circular pattern, and it's tack welded about every 5 feet going around. And you're doing basically the same thing as the sidewalls now that this attachment system's down. You're laying your insulation panels down, bring 2 together. You're putting a stainless steel strap around this round bar, bringing it up between 2 panels, and then seaming those panels together. And that creates, just a good weather seal. Anywhere you have any kind of penetrations where you've got a manway or a nozzle on the roof, we'll bring that insulation real tight up against that nozzle and then caulk around it to create the weather seal. At the edge of the roof, we weld these clips on, and these are, we call them roof edge clips. And the purpose is to bring the insulation on the roof out past the sidewall insulation. And you'll see in this next slide that we'll take this aluminum extrusion or flashing, and we're bolting it to the face of that clip I showed you in the last slide. And then here you've got the top of the insulation from the roof, and the water or snow is just going to flow right off the roof and go down the sidewalls, and basically prevents it from getting back behind the insulation itself. So that's the flashing system, transition between the roof and the sidewall. And one of the last things we do after insulating a tank is put inspection ports in. Typical inspection port is 2-inch diameter. It's got a lanyard attached to it with a plug, and you can just pop the plug off, look inside, and see the sidewall of the tank. And really, you're looking for corrosion. And we'll place these inspection ports in key spots. If it's up on the roof and you've got a nozzle or a manway nearby, you want to put it down weather of that, just to see if any water's potentially getting under that roof and causing any corrosion. Down at the bottom of the tank is another typical spot where customers like to put it, just so they can see if there's any type of corrosion occurring there. So not only are we insulating the full tank, but then many times customers will have repairs that need to be done to insulation. And they can occur on the roof, the shell. They can need to do some repairs and cut a door sheet inside of the tank. And so what do you do with the insulation then? And then you have to re-insulate it. You get anything from broken cables, wanting to do annual maintenance, and repairs to horizontal insulation systems. Speaking of, so here's a horizontal insulation system that's failed. And in this case, we came in and we welded clips to secure the bands that are holding what's left of this insulation system. And at that point, you just try and save what's left. Here's a similar picture where water's probably gotten back behind this insulation. with these insulation panels stacked on top of each other, it just creates so much weight, gravity starts to take over. And then you can see here how the insulation panels are just bulging out because there's so much weight pushing down on those insulation panels above. So we've got a method of being able to repair this, get all these bands tightened back up and get everything snug back up against the tank so you don't lose the rest of that insulation system. Also on the roof, weather can wreak havoc on insulation systems. And here what we would do is just come in, strip off this insulation here that's been exposed, do an inspection of the attachment system to see whether it's still intact, if there's any corrosion, can it be repaired, does the whole thing have to be stripped? But we can do those inspections, possibly patch it, or maybe have to strip and re-insulate the whole thing. And then here's a door sheet that I was mentioning to you, where they cut out a piece of the tank. They probably need to drive say a skid steer in there to clean out the tank. Well, before they cut that out, we came in and welded some clips on the sidewalls of the tank to help secure the insulation panels on the left and the right side of that door sheet. And then also at the top of the tank, we welded on a support system to support that insulation up above. Also, the cables that are underneath of the standing seam vertical panel system, they can sometimes fail. Way back when they first started installing this type of system, they used galvanized cables versus stainless steel cables. And we've seen some of those galvanized cables fail over time because of corrosion. And one of our solutions to try and save the insulation system is to put these cables on the outside of the tank to try and just get everything secure. So once they've finished cleaning the inside of the tank, they're going to go back and they're going to weld that door sheet back on. And then we'll re-insulate that. We'll reconnect these cables going across and then re-insulate so that it'll look exactly as the rest of the insulation on the tank. So very quickly, I'd like to go over some Belzona materials that we use to do some repairs on tanks. As I mentioned before, you got that critical weld down at the bottom of the tank. And one of the Belzona solutions that we've got for that is called Seal a Tank. And this is basically a flexible membrane that we'll put on that corner weld and then apply a Belzona material over top of that, wetting out that flexible membrane. And what this allows to have happen is any water vapor that is underneath of that tank or underneath of that flexible membrane, it'll be able to escape out. But at the same time, any moisture that's on the exterior of the tank won't be able to get underneath of it. So it's a good solution to help protect that corner weld and prevent it from getting any corrosion. One of the other things you see too is if you've got a corrosive product in a tank, it could potentially put a hole in the sidewalls of the tank. And if you're able to get that liquid level down below where the damage is, we could come in and put a patch over that. And that could at least temporarily get that tank back in service until at some point it can be taken out of service and a permanent repair can be made to it. And then also for floating roofs, you can see here there's a nipple up on the top of the floating roof, and there was a leak that occurred here, and we were able to put a Belzona flexible material over top of that leak and be able to seal that up. And again, once the tank is taken out of service, they can come and do a permanent repair. But something like this we were able to get the tank back into service until the time when they can schedule a time to be able to take that tank out of service and make the permanent repair. So some takeaways we'd like to leave with you from this presentation. The market itself has been changing with everything that's happening with crude oil, and we're seeing a lack of capacity to be able to store this crude oil, and we just want everyone to know that we've got some solutions out there that might be able to give you a little bit more reliability and expand your capacity. So with that, I'd like to hand it back over to Arya, and we could go into some questions and answers from there.
All right, thank you, Dave. Let me just get us started here. All right, thank you, Dave and AJ, for a great presentation. If you'd like to learn more about Think Big Storage Tank Solutions, please visit our website at www.banksindustrial.com. After this webinar, you'll receive 2 follow-up emails, one thanking you for attending, and another with our free downloadable for the API 653 best practices for insulated storage tanks. At this time, we're going to move into our question and answer section. And to get us started, AJ, in your opinion, where do you see the cost of oil going in the next 90 days?
Well, that's an excellent question. And, you know, oil is ultimately driven by supply and demand. Right now, there's a lot of supply and there's not a lot of demand, so the price is low. What happens to that price is going to be completely dependent on what happens with the overall economy, not just in the United States, but around the world, and how essentially we restart with the COVID crisis amongst us. It's going to depend on what happens in the fall. So unfortunately, my answer is, if I knew that answer, I would end up being a very wealthy person, and I don't know that answer. It's really just filled with a lot of variables, and a lot of people are trying to figure that out right now.
All right, thank you, AJ. Dave, I would like to go back to one slide that we had here. In this slide, it seems like there are 2 types of insulation here. Can you just speak on that a little more?
Sure. So you'll see that this is the, I don't know if you can see my pointer. No, you probably can't see my pointer. You'll see the tank and the edge of the tank, and then you've got some loose insulation, which is fiberglass, and then next to that you have polyisocyanic foam board, and that is what we call a composite panel. And the reason that's there is, more than likely, this particular tank is an asphalt tank. Asphalt tank operating temperature is typically in the 300 to 350 degree range. And the fiberglass insulation can handle those kind of temperatures, actually considerably higher than that. But that polyisocyanic cannot handle that temperature. The max temperature that can handle is 250 degrees. So we put the fiberglass up close against the tank because that can take the heat, and then the polyisocyanic behind that. The reason we don't use all fiberglass is because the polyisocyanic has a better R value, or better insulating characteristics, than the fiberglass does. As an example, 1 inch of fiberglass has an R value of 4.5, where the polyisocyanic has an R value of 6.5. So if you can use the polyisocyanic, it's better because it just insulates your tank better. But that's why in this particular scenario, this is probably a hot tank, and we wanted to get that fiberglass up against it to protect the overall insulation.
Great, thank you. Another question, let's go back to non-weld options. If you have to work on the roof of the tank, what options do you have for not welding the roof?
Sure. So there's really kind of 2 different options. One is a Belzona material that we have, we call Belzona super metal. And what you're welding this round bar that we talked about previously on the roof. Well, we can also take clips and bond those clips to the tank roof, and then attach those clips to the round bar, and this will create your attachment system, and you will not have to weld. So that's one option, and we've done that before, and we've done it successfully. Another option too, depending upon the size of the tank, is you can cable the roof, where you're bringing your cables down to around the roof edge, and you're basically creating a spider web pattern on the roof, and you're bringing it all the way up to the center vent. And you've just got cables going back and forth on the roof, and then you're attaching your insulation panels to the cables. So it really depends on the size of the tank, but we've got both of those options available to us if we can't weld.
Great, thank you. Dave, another question for you. Realistically, how long would it take to get an out of service tank up and running again, being fully insulated and operational?
Well, that's a little bit of a loaded question. It really depends on the size of the tank. You know, everything's based upon square footage and how many square feet you can get insulated a day. You know, just to give you an example, we're doing a tank that's about 150-foot diameter, and it's 48-foot tall, and we're getting that done in about a month or about 30 working days. So, you know, obviously it's a smaller tank. You could do it faster. Larger tank, you know, it'll take a little bit longer. But there's a lot of different intricacies that go into each tank. You know, the steps on the roof, the thickness of the insulation, how close or tight one tank is to another. But in general, if you've got 150 foot by 48 foot high, about a month.
Thank you. Another question we have here, is double seaming the panels better for water intrusion?
Yeah, absolutely. And really, it's our standard. You know, some other insulators may only do a single seam, but you know, as you have that stainless steel strap coming through those two insulation panels are wrapped around that cable, we'll go through with a first pass and just get everything up against the tank and do the whole tank that way with that first pass. Then afterwards, we go back and we do a second pass where we're going to do a second fold or a double seam. And this really helps keep that insulation free from any kind of moisture getting back behind it. So yeah, we highly recommend a double seam.
Thank you. Are you able to insulate a tank while it is in service?
Yes, you can, with some caveats. If it's, you know, if it's a 90-degree day, middle of the summertime, and it's an asphalt tank, and that tank is operating at 350 degrees, you don't want your guys working up there. You know, you get into some real safety concerns there. But generally, you know, if you've got a tank operating at, say, 100, 150 degrees, and you've got to insulate just the sidewalls, yeah, we've done that on more occasions than not, because, you know, customers need to get those tanks back in service. So many times we will insulate a tank that is in service, but you know, you just have to look at each individual situation and just make sure it's safe for the guys.
Thank you. Really good question about Belzona repairs. When making the Belzona repair on the tank roof, if you can't grind or create spark, what's best practices for surface preparation?
We'll just do a hand surface preparation, just using sandpaper or some sort of rough material to try and get a profile so that Belzona can attach to that roof. So you know, if there's any kind of corrosion up there, we'll try and get that away with get rid of that without using just using hand tools. Not using any kind of grinding equipment or sandblasting, for instance. But really, ultimately, you know, you got to be able to get a good profile so that Belzona can stick to that clip, and it could also stick to the roof of the tank.
Great. With that, we're going to conclude our webinar. Thank you so much to Dave and Ajay, and thank you to our audience for attending. You will receive 2 follow-up emails, one with the best practices downloadable, and another with contact information for our panelists today. So if you have any follow-up questions, please direct them to our panelists. Thank you again for coming, and we hope you have a wonderful rest of your day.
Thanks, Arya. Take care, everyone.